So we're going to take the addition property of logarithms, where we take log base any n a plus log base any n of b, and we get log base any n of a times b. An example of this, I'm going to add log base 3 of x plus log base 3 of x squared plus log base 3 of y. It is very important that all of these logarithms have the same base to use the property. If they have different bases, we cannot use this property. When we add it, our result is going to be a single logarithm, so just one logarithm with the base 3. And in there, we will have the x squared, and the y all being multiplied together. And of course, we'll want to simplify this a little bit, giving us log base 3 of x cubed times y. And that would be our final answer to this. Now, what I would like to do is prove that this is the property of those logarithms. And again, mathematics is all about proof. In mathematics, we create the math. So, let's start off with our proof. I'm going to start off by letting log base n of a. All I'm going to say about this right now is it has a value. I'm not exactly sure what that value is, but I'm going to say that it simplifies to something, and in this case I'm going to say it simplifies to the value x. And I'm also going to let log base n of b be represented by a single value. I will call that single value y. Now, let me read you the first sentence. The exponent that I place on n to get a is x. Meaning that if I take the n and I place the exponent x on it, I will get the value a. So those two statements are equivalent. Over here, the exponent I put on an n to get the value b is y. Therefore, if I take n and I place the exponent y on it, I will get the value b. Now I'm going to apply some property of equations. The first property of equations I'm going to use is the multiplication property of equations that says if I take this first equation, n to the x equals a, then I can multiply both sides of the equation by anything I want to as long as I do it to both sides. So on the left-hand side, I'm going to multiply it by n to the y. And on the right-hand side, I'm also going to multiply it by n to the y. Oh, wait a second. Yes, that is n to the y, because look at right here. N to the y is b. So anywhere that I see n to the y, I can also write b. I'm really doing two steps in one, but it should make sense. Now I'm going to apply the property of exponents. I have two bases that are the same, and I'm multiplying. What do we do with the exponents? That's correct. We're going to add our exponents together. So this becomes n to the x plus y. I'm adding the exponents. Over here, I'm just going to write it as a times b. Now, I'm going to write this sentence using logarithms. First of all, let me read it with the property of exponents. If I take the exponent x plus y and place it on n, I get a times b. That means x plus y is the exponent I place on the value n to get the value. What value do I get when I put that on the exponent? A times b. Almost done. Notice, what did we start with x being in the first place? X is the log base n of a, and y is log base n of b. Therefore, I can use substitution and substitute out the x and place log base n of a, plus get rid of the y and replace it with log base n of b, and I get their answer, which is log base n of a times b, which I just brought down from my last line. And hence, I have generated the proof.